Right, grade 7. So you're moving on to Unit 5, Heat Transfer. This is on page number 112 in your textbooks. If you just pause the video and grab your textbook and make sure that you're following along, it's just important that you understand a few key concepts before we move forward. Okay, so in this unit you'll be learning about heat energy, as well as the transfer of heat energy and how it gets from a hotter part of a system to a cooler part of a system. And then there's three methods that this can happen in, and we'll briefly touch on that now in this video. So firstly, before we move on, we need to look at the difference between heat energy and temperature. Right, so with temperature is just the measure of how hot or cold something is. And we use an apparatus called a thermometer to do so. It could be an infrared thermometer or a mercury thermometer. Most of the time in science we use a mercury thermometer. And you should remember with a mercury thermometer that mercury is the only metal that's liquid at room temperature, and as you add heat, the mercury expands and it'll start to climb up the thermometer and then give you a reading of however much it may be. In this case, let's say it's 36 degrees Celsius. Right, so with regards to temperature, we need to know that it is just a measure of how hot or cold something is using the apparatus of a thermometer. It's vital that we use a thermometer to tell us how hot or cold something is, and not just go by feel or touch, because what one of us may see as cold, someone else may see as warm. Okay, and that's what practical activity 1 does. So practical activity 1 is something that I would like you to complete at home, and you're just going to have 3 beakers or bowls with different temperatures of water. So you'll have one bowl with hot water, one bowl with cold water, and one bowl with ice water. And then you do follow the practical activity on page number 113, and you'll see that if you had your left hand in hot water and your right hand in cold water, and then you put both hands in water that was room temperature, the hand that was in hot water would feel cold, and the hand that was in the cold water would feel hot. And that's why we have to use a thermometer, because we can't by touch or feel is not 100% accurate. Okay. So you should be fine with temperature, but now what is heat energy? So heat energy is the amount of energy that's generated through heat by moving particles. Okay, now I know that may seem quite complex, but it is quite easy. So you've learned about the particles of matter. So we know that a solid has tiny particles that are very closely packed together. Okay, and while I'm busy drawing this, you must remember now that the law of conservation of energy says that energy cannot be created or destroyed, it can only be transferred. All right, and that's what we're looking at now, is heat transfer. So when we add heat to a solid, let's say for example a metal, okay, we'll say that this is a fire. When we add the heat, what happens is these particles start to move faster or more rapidly. The more heat you add to the system, the faster these particles will move and the hotter it will become. Right, so that's pretty much what heat energy is. Now the energy is being displaced into this solid, and by doing so the particles start to move rapidly. If you add too much heat or excessive heat, it will eventually change state. And what I mean by changing the state of matter is it'll then turn from a solid into a liquid, because it'll start to break down. Right, but all you need to know for the time being is that heat is a type of energy which will make something feel warm or hot. Okay, and that's the heat energy that is being transferred into this material. Now, how heat is transferred to objects is the next thing that we'll look at. So there's a few things. First one being conduction. Now with conduction, that's a transfer from one place to another using a solid object. And we're going to explain this in more detail in the coming weeks. The next one being radiation. So now that's a transfer of heat over a long space. Okay, so through a radiator, UV ray, etc., something like the heat that we get from the sun, that's via radiation. And then the next one being convection. So convection is usually the transfer of heat through a small space, and you also maybe have heard of a convectional current. Okay, and that's just meaning that hot air will rise and cool air will sink. Okay, so convection also travels through air, but not as far as radiation. And this we'll explain more in detail. It's just important that you know the difference between the three. So for this week, grade 7s, you're going to be looking at, and sorry, before I carry on, at the bottom of page 113 where it says heat is transferred to objects, it just stipulates that when heat energy is added to a part of a system, it makes the temperature of the part of the system increase and get hotter. When the system loses energy, its temperature drops and it gets cooler. It says heat is transferred from parts of the system that have more heat energy to parts of the system that have less heat energy. So the transfer of energy carries on until all the parts of the system either have the same amount of heat energy and are at the same temperature. We can show heat transfer in the following diagram. Right, and what the diagram gives you is they just say to you that this would be the hotter part of the system and this would be the colder part of the system. And then the heat would transfer into the colder part of the system until both are the same temperature. So let's say, for argument's sake, a human being is usually 36 degrees Celsius, all right, between that range, 36 and 37. So let's say 36.5 degrees Celsius, all right. And then let's say that person had a bunch of coins in their hands, and the coins were left out at room temperature and they were a lot colder. So let's say the coins were 15 degrees Celsius, just for argument's sake. As we hold the coins, because we are warm-blooded, our body is able to generate heat and keep our heat constant or temperature constant. So you learned that in the first term with regards to mammals and warm-blooded animals. So as we hold the coins, the heat then gradually transfers into the coins, and the coins will become 36.5 degrees Celsius if we hold them for long enough. As soon as we put the coins back down on the table, they'll generally start to lose heat, and that is through convection. It'll lose heat back into the atmosphere. And just to touch on quickly what is conduction, this would be an example of conduction. As we hold the coins, the heat transfers into the coins. So I don't expect you to understand what the difference is between conduction, radiation, convection as yet. So don't stress if this is not making sense. The only thing that I really want you to understand for today is that heat can be transferred in the form of heat energy. And when the heat is added to a solid, these particles move rapidly. The faster they move, the hotter this will become. Temperature is a measure of how hot or cold something is using a thermometer. We have to use a thermometer in order to be accurate because we can't just go according to feel. I'm sure you've seen some of your classmates. Someone may feel cold on a warm day, whereas you walking around with a short sleeve and they maybe have a jacket on. It's just the same example as to why we have to use a thermometer in order to say how hot or cold something is. And then just to touch on, know that there's 3 different types of heat transfer for now. It's conduction, radiation, convection, right? And that heat will always be transferred from the hottest part of the system to the coldest part of the system until both are the same temperature. Okay, grade 7s. For the work for this week, it's practical activity 1 on page number 113. Just to quickly go through it, it says here the aim of this activity will find out whether water feels hot or cold. And you're going to be going through that for me. It's pretty simple. You don't necessarily have to use 3 large beakers or bowls. You can fill a basin up with water. Just find something that can hold water for you, and then you'll experiment with practical activity 1. And then on page number 114, with the types of heat transfer, we've already spoken or just touched onto the 3. For practical activity 2, you'll investigate how heat is transferred, and it's going to ask you through a lit candle, an ice cube, or a block of ice, or a bowl of cold water, and you'll follow that method again to feel the different temperatures against your face. Alright, so this is all that we're doing for this week. Next week we'll move on to heat transfer as a form of conduction, and we're going to go into conduction in more detail. But for now, this is just the basis that I want you to understand.